Hello, welcome once again. This time we're going to be delving into the concept of the computer and the check engine light. Now, we're all familiar with the check engine light, especially when it comes to time for inspection. You can't pass inspection in your car with that check engine light, but we can use it to give us a detail or an idea if something good is happening. For instance, for example, the power control module, which is a main computer module. Its first task is we have to give it 12 volts. If you look at this, see the dotted line around this? That means there's another part of this computer module. And believe me, there's about 200 pins of this computer module. As you can see over here, there's connectors. See these little triangles? These are connectors. These are the pin numbers. 19, the pin number for ignition voltage, 1. Pin 46 for connector C2, which controls, as you'll see over here, the malfunction indication light. Class 2, that's its communications network. The power control module, we'll abbreviate it, we'll say PCM. PCM is going back and forth, talking to many modules, looking for data, looking and always browsing around and inspecting what's going on, what's the trouble, what's the results, what are my sensors telling me. So in order to get that information, he has to be in communications with the other modules, with the other sensors. The sensors that we'll go over shortly: mass airflow sensor, input air temperature sensor, coolant temperature sensor. He has to know how much air is entering the engine, the temperature of the air entering the temperature, the engine, the coolant temperature sensor. He has to know the temperature of the coolant in the engine. Why? Because he has to open and close the fuel injectors in order to get more fuel or less fuel into the cylinders based upon air. More air, more fuel. Less air coming in, less fuel I will pour into the cylinders. So this is his communications, class 2 serial for GMs. It's like his, let's say his internet, okay? We know our internet to communicate. This is his internet that he uses for information. So fine. This is his information data line. This is the ignition 12 volts that he gets. And again, we have more battery positive voltages, also 12 volts that we'll go over. He needs more than 112 volts. There's a lot of modules in here, and there's a lot of circuitry in here. So now we established the fact what its purpose is. Before we go to the diagram, we've been going over diagrams slowly. A ground symbol. The ground is a physical ground. Wherever you see G103, it's a physical ground. Okay? Wherever you see S106, it's a splice. Many wires coming into one connection. As you can see, this wire coming here, this wire, many wires. But they're all going to eventually to a ground. So, as you see over here, G103 is a ground. G105 is a ground. Another splice, S152, another many wires coming in. From pin 24 coming in, from 27 coming in. See, these are ground. All these grounds coming into a common point to the physical ground. Because why? Two things should come into your mind when it comes to, when I say the word PCM. You should remember controls air, controls fuel, controls combustion, controls compression, controls the power of the engine. The better the air-fuel ratio, the more power you'll get out of your engine. The more horsepower, the more torque. The more better the emission, the exhaust that I made a video about how an engine works. There's input, there's output. The output is the exhaust, the byproducts after everything has been combustorized, if there is such a word, or burned. You get the byproducts of what's left from the air-fuel ratio. That goes to the exhaust, and then it goes to, obviously, goes to the tailpipe. We want the emissions to be proper. In other words, hydrocarbons, carbon monoxide, carbon dioxide, oxides of nitrogen, all these byproducts coming out of the exhaust should be within limits so that we have proper emissions. That's our goal. Now, This over here is a physical ground. This is also a symbol of a ground. See a symbol of a ground? But you don't see G105, G10. You know why? It's not a physical ground. It is a ground within this computer module that it gives to you or it takes away from you. Let's explain further. When we want this circuit over here, we're going to go over it. But before that, we have a battery. We go through a fuse and ECM1. Whenever you're looking for the computer fuse, look for ECM or PCM. That right away tells you. It goes through a fuse and current will flow, come out the other side. Only 15 amps, remember. Doesn't take too much current. Not too much. When you see blower motors or things like that, sometimes they're 30 amps. So ECM is a very small fuse, a mini fuse. The current goes in, comes out of C2, which is the connector, terminal 810, a pink wire. Pink 0.5 is the gauge. So you're going to be looking for a small wire. A small wire over here, going in here into C1, a connector C1 19. Hope you can see that. Now, if you want to look for the connector, two things. C2, you come over here and you say, okay, C2 is my connector. What kind? Connector ID. I look for black over here. See? C2 is black. So C2 is a black connector. That's what I'm going to be looking for. And the wire is going to be a pink one. And what type of wire? A very, very thin wire based upon 0.5 gauge. So we're going into it. We're giving him voltage at pin 19. That's first is first. Then we give him a ground. Two things a computer needs. B plus, maybe more than one, maybe more than two, maybe three. And the ground. Those are the conditions you have to give those computers. Now, getting back to this. So now, again, if you see this over here, hot and run and start. In the run position, we give current through the fuse. Gauges fuse number 4, which is rated at 10 amps. Current flows here through a pink wire. What's the gauge of the wire? 0.35. What does that tell you? Very thin wire again. Through this, what is this? A service engines light, the check engine light. The one we hate to see all the time, but it's there all the time, unfortunately. So this is called the LED. You see the arrows going out? That means this lights up. When this is active, light goes on and it tells you something. Either it's red or it could be green. So this is in this little instrument panel, which is in the dashboard. All those lights that turn on when you turn on the in the run position the key, or the lights come on, they're going through a self-test. They're making sure all the bulbs are working, everything is working, all the malfunction lights are working through a self-test, a boot-up test. Now we come into here. We come to, again, which one? A terminal connector A11, going through another connector, C203, going through a plug, actually, P100, going through another connector, C101, going through another connector, C2, at pin 46. Look how many connectors we went through. Wow, wow, wow. But they're all rated. Look at all the color of the wire. Brown with a white stripe, brown with a white stripe, brown with a white stripe. And 0.35, 0.35, 0.35, the gauge. Now, this will give it a ground when this has to be lit. And when is that? That's in the very beginning. When you put in the run, before you even crank, this puts it in a run position, and this lights it up. Make sure everything is working. The problem is, check engine light goes on. That's okay. It's supposed to go on. Why? I started off this video and I said, sometimes it could be for good. Well, the fact that the check engine light comes on as a self-test tells us what? Tells us that this has 12 volts. The computer is getting its 12 volts. That's good. That means the fuse, which is ECM1 fuse, is operating. It's not blown. It's giving it 12 volts. It's getting it 12 volts in this one. ECMB, ECM1, ECMB is good. All the voltages are going to this, to the computer, and it has a proper ground. Therefore, it closed this ground to self-test this one. That's our indication number one, that the computer is getting its voltage and its ground. It doesn't mean that all the pins are operating correctly on the PCM. Remember, PCM can have 200 pins. Doesn't mean pin 199 is working correctly, but it just means that 12 volts going here. This is giving it a ground. It's giving it a ground. It's not a physical ground. It's giving it a ground to self-test it. Condition number 1. That's great. So at least we know this far. So far, it's working. That's what I meant by it could give us something good, an indication that's good. So that's how the PCM works. Okay? Now, take that detail with you, and we're going to transfer that detail to the next video for sensors. It's going to be a little more in detail, but if you understood this, and like I said, please go to my channel for how to load test batteries, corrosion on terminals, and all these things. Especially I'm working on, my channel is Automotive Electronic Schematics by Joseph. This is my other channel. I'm working trying to get those views. I'd like to thank the comments of many, not many. I wish I had many viewers, but I have some viewers anyway. Viewers that I have. One who was very nice from. I love to see comments from other countries. From I think it was Egypt. Glad to hear from other countries that they're watching my videos. It's a great compliment. Welcome to the country of Egypt. Thank you very much. And we're going to continue the next video. If you enjoyed this video, please give me a like and subscribe to Automotive Electronic Schematics. We're going to continue to the next one.